you have 3.50 liters of a solution that contains 90 grams of sodium chloride, NaCl. What is the molarity of that solution? So with any problem involving molarity, the formula for calculating the molarity is, which is denoted by big M, moles of solute divided by volume of solution, or moles per liter. That's how we calculate molarity. Now, analyzing this problem, let's see what's given and let's see what's unknown and any information required so that we can come up with a plan to solve this problem. So given 3.5 liters of solution, that is going to be our volume. 3.5 liters, our volume is given to us. And also given to us is 90 grams. 90 grams of sodium chloride. And this is the mass of the solute. And our unknown is asking, what is the molarity? So our unknown is molarity. And we have our volume, and we're looking for molarity. We need moles of solute. That's required. Moles of solute. We don't have that, but once we get that, then we'll go ahead and plug that into the equation. So our plan for dealing with this is going to be as follows. First, we are going to convert grams to moles. Once we convert grams to moles, we will have the moles of solute, and then we will be able to do our second step, which is plug in the information into the equation in order to isolate the unknown variable, which is already isolated as molarity. So we're just going to plug it in and then solve. So that's going to be very simple. So our first step, converting from grams to moles, let's go ahead and do that. So we are given, let's see, 90 grams of sodium chloride. In order to convert from grams to moles, what's required is the molar mass of sodium chloride. The molar mass of sodium chloride, that's required in order to do this step. So why don't we go ahead and find that molar mass? Looking at the periodic table, and our mass of sodium is 39. Our molar mass of chlorine is 35.45. So if this is 39, no, wrong. Sodium is Na, 22.99. 22.99 for sodium. For chlorine, 35.45, and we just add them up, and our molar mass for sodium chloride ends up being 58.44 grams per mole. So this is the molar mass. And now that we have this, I can use that to convert grams to moles. So taking my given quantity, 90 grams of sodium chloride, I'm going to set up my conversion. 90 grams of NaCl over 1, and I'm going to multiply that by, now I have grams in the numerator. I want to put grams in the denominator so that it cancels. So I'm going to take the molar mass, 58.44 grams of sodium chloride, which is equivalent to 1 mole of sodium chloride. And now that I have grams up top and on the bottom, they cancel. And now I just multiply across the top. 90 times 1 mole NaCl is going to give me 90 mole NaCl. Divided by 1 times 58.44, 58.44, and when I finish solving that out, it's going to 90 divided by 58.44 equals 1.54 moles of sodium chloride. So now I just converted grams to moles, and I found the moles of my solute, which is actually required to solve this problem, which is 1.54 moles of sodium chloride. So now that I have that, I can move on to the next step in my plan, which is to plug in the information into the equation in order to isolate the unknown variable and solve. Now let's remind ourselves what that equation is. That equation for molarity is moles of solute divided by volume of solution, and we just found moles of solute, which is 1.54 moles of NaCl, and now volume of solution that was given to us in the problem, that was given here, as you can see, 3.5 liters at the very top, that's given. So let's go ahead and put that in there, 3.5 liters. And when you do 1.54 divided by 3.5 liters, that is equal to 0. This is molarity. Molarity, big M, equal to 0.44 molar solution of sodium chloride, and this is our final answer.